Hi everyone, this is Darren here, and today I'm going to teach you more about algebraic identities. So these algebraic identities, they are actually three very well-known ones. They are very much needed when we are doing factorization or even expansion. But generally, more often than not, it is going to be used when there is some factorization involved. You need to know these identities by heart, and you must be able to have some pattern recognition. So like if you see an equation that is similar to this format, you must be able to identify that, hey, this is the identity, and then from there you are able to factorize or expand. Okay, so now what are the three identities that I want to show you in this video? They are simply, the first one is a plus b square equals to a square plus 2ab plus b square. Okay, so this is one identity. So they call it identity, but actually maybe the word confuses you, but I would say that identity is more like a shortcut formula. Okay, why I say that is because a plus b square is going to be this, but actually you also can work it out on your own. Let's say you forgot, right? What is this? You can actually work it out in the exam. Maybe you forgot. So what you can actually just do is expand a plus b, right? So you're just going to rewrite this. A plus b square, you're going to rewrite as such. And now, you just expand it. What do you get? Remember? A times a times b times a, b times b. So this will give me a square plus ab, and then plus ab, and then plus b square. So therefore, this will just be, these two can be simplified further. So we get a square plus 2ab plus b square. Okay? So there we have it. If you forget what a plus b square is, you can always just expand it and get the answer again. So this is one of the identities. There will be more identities also. So more identities would be such, okay, there's actually two others. So let me just show you the second and third one. So this is the first one. And now the second one will be a minus b square equals to a square minus 2ab plus b square. And the third one would be a plus b, a minus b equals to a square minus b square. So what I want you to do is, maybe you can pause the video and you can actually test it out, verify that these identities are true. So I want you to do this, expand on your own and see whether you get this, and do this, expand this on your own and see whether you get this. Okay, so pause for a moment. Okay, now let me move on. Assuming you've done that, you realize that they are indeed true. So these identities help us. Now, I'm going to focus on just one identity, but take note that the lessons I'm going to teach now really applies to all three, okay? So what happens is, this identity, right, is the formula. So a plus b square, okay, we get this. In a lot of questions, we have maybe something like this instead. Maybe we have this as x plus 3y, okay, square. And they want us to expand this. So now, normally, if you were to expand this, yes, you'll do x plus 3y, x plus 3y, and you could go about solving, right? You can go about expanding. That is one way, yes, but now that you have learned identities, you can actually use the identities to help you to solve this in a shortcut, in a faster manner. Because how? What happens is, we have to realize that this and this, there is some similarity, right? They both have two terms and they're both in brackets and square. So now what does this mean? It just means that this part here is A, and whatever this part here is B. So what you can actually do is, use this formula on this equation. So you treat x as A and 3y as B. So this is a trick. You're going to, whatever it is, maybe this is even if this was, let's say, 4x, right? Then you treat the whole 4x as a. Even if this is 4x squared, you treat 4x squared as a, okay? So just follow me, okay? So anyway, back to the first example. We have x plus 3y. So now we're going to treat x as a and 3y as b, okay? So x as a, 3y as b. And now, what happens is, we're going to apply this formula. So we know that this plus this is similar to a plus b squared because it is in the same format. So therefore, the answer will be in a squared plus 2ab plus b squared. So therefore, this can actually be using the identity quickly. We can get x squared plus 2x 3y plus 3y squared. Okay, you see? Yes, this is the trick, and this is the whole point of this video actually. If there's one takeaway for this whole video, would be that whatever the identities, right, can always be used, whatever the equation, if it is in the same pattern. So now what's happening is, yes, please take note on this. So I'm using notice the x squared is like the a squared, right? And the 2 is still here. I'm just using the formula, and now I'm replacing the a here with an x because this is our a, and the b here with our 3y, see, times 3y. And then the b squared will just be 3y, right? So 3y whole thing square. So therefore, this will give me x squared, and this will just expand to 6xy, plus this will be 9y squared, okay? So this is the answer. Okay, so this is one example. I would like to do another example, okay, to really illustrate the point. And that's really the main takeaway and the only takeaway for this video. I really want you to understand this. It is so key in so many, and it carries a lot of marks in the exams also. So now, okay, I'm going to say now maybe I have 5f plus 6g squared. Oh, you might be thinking this looks really different. No, but actually it doesn't look different, right? Because it's still two terms in brackets being added together and square. So you see, these two terms that are in brackets, they are being added together by plus and they are being squared. So same thing actually. So again, the trick here is to treat this whole chunk as a, this whole chunk here as a b. Okay? So now we just use this formula again. Therefore, this will just be 5f squared, because 5f is, our 5f is a, right? So we're going to be, we know through the formula is a squared. So 5f squared plus 2, 5f, 6g plus 6g squared. Okay? Hence, I expand this out. 5f squared will just be 25 f squared. This will be 2 times 5 times 6, giving me 60. Okay, so 60, then f and g will come down, so 60fg, and 6g squared will give us 36g squared. Okay, so this is the second example whereby we used the identity. So now let me move on to let's use another identity. Okay, they're actually all the same, but just for your curiosity's sake, let's just use other identities. Okay, so now I don't want this identity, I want to use the minus identity, right? So I'm going to say a minus b squared is equals to a squared minus 2ab plus b squared. Okay, and now what do we do? Let's say the question was 3x plus 4, sorry, it should be a minus, right? Because we want to use this negative sign, yes. So it's going to be 3x minus 4y squared equals to, okay, again, use the identity straight away. So we know now that this is our a and this is our b. So oh yeah, there's one thing that we must take note. Sometimes some people might, if their memory is slightly faulty, they might forget. They might think, hey, actually b is minus 4y. See, if they think b is minus 4y, then we have a problem, okay? So that's wrong. So you have to take that b is 4y and not minus 4y, because sometimes people make a mistake like this. It's a common mistake. So please take note. Okay, so now we're going to use this formula. What do we get? This is going to be 3x squared minus 2 3x times 4y plus 4y squared. See? This is much faster than rather me expanding out, just listing out these two in two brackets and then expanding out and working on all four of them, all the four terms out, and then slowly simplifying. Because by using this formula, it really saves me time when we have the same pattern here. So that's the purpose of identities, okay? So now, let me just finish this question. So this will be 9x squared minus 2 times 3 times 4 will be 12 times 2, 24. So 24xy, and then this will be 16y squared. So plus 16y squared. So this is the final answer. Okay, now we move on to the last one. Okay, the last identity. So let's say now I want to use the last identity, right? Okay, and last identity is this. We have a plus b, a minus b equals to a squared minus b squared. Okay, so now if it's like this, then the question has to be also pretty similar, and the question must also be in the same format. So if I had now maybe 2x plus 3, okay, and then 2x minus 3. We have to check. Before I go ahead, just use the identity. Is it really in the same format? 2x plus 3. So a plus b, right? So a plus b, and 2x minus 3. So it's a minus b. So yes, so we are correct. So this is a fine example to use this identity. So we go ahead and use this. What do we do? If this is a and this is b, right? This will just be, we know the answer to this when we expanded it out will be 2x whole thing square minus 3 square. So therefore, 2x square gives me 4x square minus 9. Simple as that. Okay, so these are some simple identities. That's the basics on the identities. Hope you don't get too confused. Probably in the next video I will use more examples of identities. And take note that in these identities, really what we need to do is really lots of practice. That's how we get good with algebra. You need lots of practice so that you're able to recognize the patterns quickly and see like which identities I can use and whether I can factorize, whether I can expand, whether it will save me time, etc. So I hope that you're not too disheartened with maths, and it is I know sometimes you get some difficulties, but I will really ask that you please persevere and really master these identities, because it can actually help you a lot in the future. I hope that you learned something from this video, and as always, please like and subscribe. Thank you very much.